There you go. Something I meant to show you guys yesterday, if you hadn't done the initial quiz for chapter 2, one of the questions has you sort a bunch of decimals. There's like 10 of them. And you have the option of copying it to Excel. You can click on the little blue button thingy, the window button, and it'll copy to StatCrunch or Excel. If you put it in Excel, like say in the first, you paste it into Excel, what you can do is you can say, come up to sort up here. Oh, it wants me to select the range. I copied it into 2 squares, that way you can see what happens sorted and unsorted. Select the squares you want by like dragging. It's fucking, I hate this, there's 2 monitors. One is a second delay. And it's no matter what room I'm in, it's always happens to be the screen I'm looking at. So like, it's always like I'm moving it and the mouse isn't moving. So I need to look at the other one while I'm doing it. It's further away. All right, so here we go. I'm gonna click sort. And it will ask me, since I have other data next to it, it asks you this question. No, I don't want to explain this selection. I'm just gonna do this column. And I can tell it to do smallest to largest. And I can now see it's put them in order. So if you're trying to sort them for like the problem for the 10 things, this will save you some time. If you're trying to figure out, it puts them like which one is lower than X. It does the comparison thing. If you're doing it for 2 numbers and typing it into Excel, you're wasting your fucking time. Learn a little math. Learn how to compare 2 decimals like we covered yesterday. But if you're doing a bunch, that's tedious. Don't do that by hand. Just that. So you could do it in Excel and it'll speed it up. That was one thing I wanted to show you guys. And then the other stuff was stuff we were going like on the handouts. In fact, I'll put the handouts in a second. There's one of them is the StatCrunch stuff. So in chapter 2, which is what we were doing the interactive review for, or the review for the last couple of days, some of the ways to do the stuff in StatCrunch, they're in the lecture videos. But if you want to see them in real life, I'm going to put them here in real life. I can click visit the StatCrunch website, and I can open it, or I can click and open my data sets, and I actually have a data set already open. I'm going to come over here and do the stuff and show it from there. In chapter 2, we are doing frequency and relative frequency, and we're looking at histograms. That's the primary objectives in chapter 2 for the main stats course. You can do the frequency or relative frequency on any column. The way you do it is you go to stats, tables, frequency. And you will see that it's on the first page of the handout, one of the handouts. You tell it which column you want to do. You can collect more than one column. If you do control click, you can put spaces between them, like hit age and then hold down control and click shoe and hit control and click another one. If you do it and you use like the roll wheel on your mouse to like go up and down, like there's a bunch of columns, don't hold down control while you're doing it, because if you do, this is what happens. And you get your shit fucking going too small. So I'll put it like that. I'll just do age for now. Age, there we go. Frequency and relative frequency, let's just look at them. Maybe I want to do age. Age has got a lot of shit going on. Let's do, let's see, hair color. So it goes through the list of hair colors, and it is sorting. It said sort by order, and it says ascending. It's going by alphabetical order of hair color. So black is before brown, brown is before or blonde is before brown, sorry. Black, blonde, they're going in alphabetical order. Frequency shows how many people said black hair. So like 65 said black hair, 19 said blonde hair, brown said 113, stuff like that. Frequency can be useful, but like if you don't know how many people, all I said was 65 people had black hair, that doesn't tell you a whole lot. If there were only 70 people I asked, 65 is almost every single one. If I asked 2,000 people, 65 isn't really jack shit, right? So frequency isn't a great number. It's useful, but it's a limited use. Relative frequency is when you add up each, or find the frequency of each group, add up the total number of people present, or however many that responded. The computer does that for us. It says the count is 213. It has gone through and divided each number by 213. 65 divided by 213 gives us this value. If I write these as percentages, like we were practicing yesterday, the black-haired people had 30%, 30.5%. That seems high to me. I don't see a lot of black-haired people. I see way more brown-haired, but I guess there are actually a lot in here. There's a lot of black-haired people in here. Crazy. Maybe I just don't fucking pay attention enough. And so, like, we can turn each of these in percentages. Blonde is 8.9%, like 9%. Redheads are down at 2%. So like that gives me more. I don't need to know how many people I asked. I know like there's not many redheads if it's 2%. Brown hair is 53%. Half the people have brown hair. That tells me something rather than 113 people. So relative frequency is a little more use. The other stuff you're doing in chapter 2 is histograms. You do some other charts as well, but most of it's histograms. Pie charts and stuff and bar graphs, you know what they are. You've seen them before. So you can do those here. Histogram requires us to do something that has a column with only numbers. I can't do columns with words. So like maybe I'll do like shoe size or something. Let's do shoe size. And now it gives me, if I put a cursor over any column, this column says bracket 7, 8, parentheses. We're going to cover interval notation this week, but the bracket means include the 7, and the parentheses means go up to that number, but don't include it. So this column is doing like 7 to 7.99. We know there's no 7.99 in shoe size, so this is like 7 to 7.5 shoe sizes. You might find it helpful when you're doing these you can always click options and edit a graph if you want to change something without doing it all over again. Clicking value above bar is helpful because when you do, now I don't need to try to look over here and go, how tall is this box? I don't need to put my cursor over the box to see frequency says 38. I can, without putting my cursor anywhere, see how tall each column is. So having the value above bar is pretty handy. That stuff you can, like, will help you while you're doing homework for chapter 2 in like the main course. Any questions about that? It's in the videos as well for the class. So this isn't the only spot you'll see it. All right, let's do some math. And today we are doing review for chapter 3. We're reviewing the math skills you'll need for chapter 3. So it's not like a review of chapter 3, it's a review of the math for chapter 3. One of the first things we're going to do is exponents. Now, I recall one the other day when we were doing like repeated addition, and I said like 3 plus 3 plus 3 plus 3 plus 3. We could say that was like 5 times 3. Repeated addition went to multiplication. Well, we have something for repeated multiplication too. I do 3 times 3 times 3 times 3 times 3. This can get tedious to write out, especially sometimes you're doing a lot. We have a notation. The number that is being repeated is called the base, and we put it like that. And the frequency, or the number of times it appears, is the exponent. And we put that up here. There are 5 3s here, so I will put 3 to the 5th power. This is how this is read, 3 to the 5th power. Most calculators have a button for it. Not every. There's like some people have like, all it does is multiplies and divides, shit like that. Oh, hiccups. But the x squared button is right there. The caret does higher powered things. So if I want to do 3 to the 5th power, I can do 3 caret 5. And it gives me the answer. 3 to the 5th power in the calculator is 3 caret 5, which is 243. Some calculators have like a Y to the X button. So some of them have different things. If you don't know what it is on yours, you can ask me. The one we really care about in here is the one that says this. Most calculators have that specifically. It might say a Y with the 2 on it, it might say an N with the 2 on it, but it's usually an X. When we have an exponent to the 2nd power, we call that being squared. This is 3 squared. And I can literally hit 3x squared equals. You will hopefully, if you know your multiplication tables, you know the x squareds all the way up to 10. It's the diagonal on the multiplication table where you got like 1 to 10 going down the side and 1 to 10 going across the top. The diagonal of that thing is the squared numbers. That's really the only exponent we're going to be using in stats. I can't think of any other power. So that's the big important one here. It's called squared because it's related to the area of a square. The area of a square, like a 3 by 3 square, is 3 squared. So it's related with the area of a square, so we call it squared rather than saying 3 to the 2nd power. 3 to the 2nd power is the same thing, but it takes a hell of a lot longer to say than 3 squared. Now, it's important to know that if I square -2 and if I square +2, I get the same answer. This says -2 times -2. And this says 2 times 2. When we multiply 2 negatives together, it makes a positive number in mathematics. Both of these are 4. How is that useful to you? There are points in here where you're going to need to square negative numbers. I'm sure there's at least one problem that has you doing standard deviation by hand, and we're going to walk through it today. And oftentimes you end up with negative numbers and you're squaring them, and trying to put a negative number in the calculator, it just takes longer to do. And it's like a little confusing, like how to enter it with parentheses. But since it comes out positive, you don't need to bother with the negative sign when you're putting it in a calculator. So where are we Is everyone ready for more? All right. Guadalupe, if you ever need me to pause, let me know. If I need to put something back out, let me know.
Okay, thank you.
Where we're going with this is, if you take a look at this bad boy, we have two formulas that we're going to be like, the big one we're going to be using is this sample standard deviation one. I'm going to write it on the notes in a second. Other formulas that'll be useful for you when you're doing like the stuff in this chapter is seeing what these symbols are, and I'll write them larger here in a second. But I'm going to write that standard deviation formula down. It's here though if you get it in a nice little handy packet. So I'll point out things in the packet as we're doing them that you'll find helpful. You will find as you're going through this class, the English letters are for samples, sample groups, and the Greek letters. And if it doesn't look like an English letter, it's a fucking Greek letter. We don't have like another language in there. Those are for populations. The only letter that is not a Greek letter for population is capital N, which is population size. For some reason, they didn't switch to the Greek letter. I forget. The Greek letter, I think, looks like a cursive N, so they didn't bother. But like the other letters look different. So we got a lot of things we got to learn to talk about how to do today. We need to talk about what this crazy funky E is. We need to address some of this other stuff. We need to talk about square roots. But let me just tell you what some of this stuff is. The X bar, we call it X bar. This is our sample mean or average. When you see the population one, it looks like this. It's pronounced mu. It's spelled MU. This is population mean. Before we kind of got to do all that stuff, doing the average has us adding stuff up and dividing. So before we get, maybe I can list what the other stuff is. XI is the individual data entries. And you'll see a little bit more what I mean by that in a little bit. Data values. This big crazy E means is summation notation. And we'll walk through doing some stuff with that so you can like get hands-on with it. This is capital sigma. Sigma is the Greek letter. Like the lowercase sigma is that. And oddly enough, this will be population standard deviation. So it has a value in stats as well. And little n is our sample size. As I already said, it's the name of the page, sample standard deviation. Everyone ready for more? Okay. So there is a lot of operations going on in here, a lot. First thing we're going to talk about is order of operations. PEMDAS. Does that sound familiar to anybody? Hopefully you've all at least heard it before. You have probably heard, please excuse my dear Aunt Sally. That's a common way of remembering the letters. So please excuse my dear Aunt Sally gives you the letters. I hate it. I don't have an Aunt Sally. If I did, she probably wouldn't be dear to me. What I do have, and what most people have, not everyone, is I don't like the dear, I don't like the aunt, and I don't like the Sally. I do have a dumb ass sibling. Siblings are brothers and sisters. If you don't know that word, most of us have one. If you're an only child, I don't know if you got it better or worse than the rest of us. I like tormenting my brother, but he liked beating me up. So many of us have those. I don't like writing it in that order. I tend to do P, E, M, D, and A, S. And the reason why is P stands for parentheses. We do this first. And when I say first, it means do all operations inside. So you're going to kind of basically, when you've got a parentheses, you're going to go through the rest of the list first inside the parentheses. E is for exponent. MD is for multiply and divide. And AS is addition and subtraction. Now we are supposed to do these in order, but both multiplication, division, and maybe I should say spell out. Both multiplying and dividing have the same priority. We do them together. So sometimes we got a bunch together. When we do them, we go left to right. And that's why when I write it, I write the M and the D next to each other. This holds true for addition and subtraction too. We're still writing. Speed. Wait for everybody. Don't rush. Go at the speed you need to write everything down. We got time. I don't see any pins moving, so I'll assume you're done. If you're not, let me know. I'll put it back. So let's look at some examples. I'll do an example with you, and then I'll give you an example to do yourself. Let's do 5 times 4 divided by 2 plus 8 in parentheses minus 3 squared. I'm gonna come over here, I'm gonna write down PEMDAS and cross them off as I do them. I think it's handy, even when I know what the hell I'm doing, but if there's enough shit going on, it helps keep my thoughts organized so I don't go fucking crazy. It's easy to go crazy. How many of you see this shit on Facebook? They're like, what's the right answer? And like, there's always like 30 different fucking answers. Usually for something way shorter than this. It's like, there's only like 3 or 4 numbers up. How do you get 30 different answers? I don't know. Sometimes I think people just guess it. Just making shit up. So let's go through it. I have parentheses. Parentheses also works for any grouping symbol, like brackets. If you see like brackets, it's the same idea. You're putting stuff in a group. Here's my parentheses. 2 plus 8 is 10. And I'm gonna replace that and I'm gonna bring everything else down. Now you can leave the parentheses on there or you don't need, once you're done with all the operations inside the parentheses, and here I am, there's nothing else to do, 10 is just a single number. The parentheses is no longer necessary. But that takes care of my parentheses, so we'll cross that off. Next thing I have is exponents, which is over here. I'm gonna write down everything I'm not touching yet. And then I'll do the exponent. 3 squared is 3 times 3, which is 9. I've done my squares, I can or my exponents, I can cross that off. I now want to do multiplication and division. I see one multiplication and one division. I go left to right, it doesn't matter what order they appear in. If division comes first, I do division. Whatever it is, left to right. The first operation I have of those is 5 times 4 is 20. I am going to bring the rest down. This takes up more paper. This avoids making big mistakes. Then I still have multiplication or division. So I'll do that. 20 divided by 10 is 2. I still have the minus 9. And now I don't have any more multiplying or dividing. And I have only subtraction here, no addition. 2 minus 9 is negative 7. That's the answer here. You guys ready for more? You guys ready to do one? I got 40 divided by 8 times 3 minus parentheses 5 times 2 minus 7 squared. Go ahead and take a few minutes to do that, then we'll do it together. Everyone ready? Oh, I'm gonna talk faster than I thought. Like be split. All right. I got 6. Did everyone get 6? All right, so we can go through this quicker then. I would go through and I'm gonna write the PEMDAS down. I tend to do, when there's the parentheses, I do that shit on the side. So we've got 5 times 2 minus 7 is 10 minus 7, which is 3. So I have here 40 divided by 8 times 3 minus 3 squared. We'll cross that off. Then we need to do the exponent. 40 divided by 8 minus 3 minus 9. 3 squared is 9. That's not a minus, that's a times. Like something looks wrong. All right, so I got my exponent done. Multiplication and division, the division happens first. 40 divided by 8 is 5. And I still have times 3 minus 9. Now I do the multiplying. 5 times 3 is 15. Minus 9. And finally, 15 minus 9 is we end up with 6. Hopefully that's review. Any questions? No? All right, next topic we want to talk about. If we look at that thing we're looking at, what else do we need to talk about? We're looking at that formula right there. we need to address the summation and we need to address the square. I think the square root is the easier thing to address first. So let's talk about that. Square roots, they have this symbol like that. I tend to write it with a little tail on the top. They're the same thing. I just do this to let me know where the square root sign ends. Because sometimes I write numbers too close to the end, and I'm like, should have that been under the square root or not? I don't know. If I put a little tail here, I know what it's supposed to be under it. This is called the radical sign. One of the best symbols in math. Radical used to be a cool word, like awesome. It was totally radical, man. It was groovy. Good stuff. So what do square roots do? They do the opposite of squaring. Or really, it undoes squaring. So, for example, if I have the square root of 64, what this says is find the number such that when we square it, we get 64. Now, hopefully, you guys know that 8 times 8 is 64, which is 8 squared. So the square root of 64 is 8. I could write this as square root of 8 squared. And I think that's a helpful way, because then you can like see this radical sign and this square, these two cancel each other out. Now, what you may not think about is that negative 8 squared, or negative 8 times negative 8, is also 64. So really, the square root of 64 mathematically is 8 or negative 8. And usually in a lot of mathematics, we ignore the negative one. We definitely ignore the negative one here. The positive one is called the principal square root. That's just terminology. In case you see it, they say principal, and you're like, what the hell is that? Jones didn't tell me that? Yeah, Jones told you that. In all reality, just when you take the square root, it's the one the calculator spits out. It's the positive one. Calculator will not spit out the negative one. And when you have a square root that is a whole number, like 1, 2, 3, 4, 5, something like that, it's called a perfect square. So this is going to be, the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the ones on the times table. Those are the perfect squares. When I take the square root, I get a whole number. Interestingly enough, there is a pattern to the perfect squares. This is just fucking fun. I can get to 4 from 1 by adding 3. I can get to 9 from 4 by adding 5. I can get from 16 to 9 by adding 7. And this pattern continues. Just increasing to the next odd number. You don't need to know that. I just think it's interesting. There's your fun, useless trivia fact for today. Okay, cast some ass on Jeopardy. You guys ready for some more? No. Your pen ain't moving. You must be ready. You guys need a break? It's been almost an hour. You just don't want to do math. How could you? Ow, that just wounds me. Where's the enthusiasm? Let's take a look at some other ones. Sometimes you don't need a calculator. Like if you have the square root of 25 over 16. This is the square root of 25 over the square root of 16. Radicals are rad like that. They do that. You can split them up like that. And this is 5 over 4. Not a perfect square, but very, like, I'll be honest. I'll be surprised if you see a perfect square in this class. I will be surprised if you take I'm sorry, let me rephrase that. I will be surprised if you take a square root of a perfect square in this class. Where you're doing square roots in this class, you just never get a perfect square. So, where does this matter to us in statistics? Well, a lot of the stuff we're going to be doing is like taking the square root of numbers that aren't whole numbers. If I do like the square root of 5, I have a square root key. Most do. This is 2.236067978. I recommend when you're doing this, write down more. Like if they ask you to do a problem where you need to write down a bunch, write down more than you need from your calculator, and then like round later on at the end. Use these numbers until you're rounding at the end. Now in my calculator, I did this. I hit the square root key, I typed in 5, and I hit equal. Some calculators do a different order. Some calculators have you put like the number in, then you hit the square root key, and you may not even need to hit equal. So like how yours works depends on you. I recommend you trying to do on your calculator, do square root of 4. Hopefully everyone knows that 2 times 2 is 4. When you figure out the right frequency or the right combination of keys to put square root of 4 in your calculator and it gives you a 2, you'll know how to use your calculator for square roots. All right, so since most of that stuff that we're going to be doing with the square root is in a calculator, I don't really know that there's a whole lot more to say. Anyone have any questions on square roots? Capital sigma. This is summation notation. You can see it has the word sum in it, and sum is the outcome of addition. So when you see this thing, it just means add the shit up. I know in the initial quiz thing for the review, they actually have you work through a little summation thing, the way they have you doing it with the indices or indexes probably won't be used in stats, but they want you to know how to do it. So the way it usually comes is it might have a number on the top, and it should have a number on the top and bottom, or it might have the number on the top with like a letter in front, which is usually a good choice. They usually have the letter. They might have an I, N is a common one. N is a common letter here. They frequently start at the number on the 1 is the bottom, and then the number on the top, these numbers change. These can be different. I just wrote 1 and 5 here to give examples, but it's any number. It could say 0 and 100. I think a better way of showing you how it works is just to give an example and show you how to calculate it. So, my first example here is I equals 1, and we have 4 up here, and I'm going to have 3i minus 7.5 squared divided by 4. Now, if you have to do this by hand, and they don't ask you to do little sub-steps, this is handy to take advantage of this kind of information. If I have 5 over 4, this is the same thing as 5 times 1 over 1 times 4. That's the same thing. And we saw when we were working with fractions the other day, when you multiply fractions, you can put them together, or I could separate them. So 5 over 4 is also the same thing as 5 times 1 over 4. So this is kind of like, I could put 1/4 here. Like that. Instead of dividing by 4, I multiply by 1/4. This is like that reciprocal stuff we did yesterday or Thursday. I don't know when we did it. We did it sometime. Now, even more handy than that is just, we can move it outside. Since it's multiplying and it does not have an I in it, I can move the 1/4 outside. That, I made it a little cleaner to work with, so it's not as tedious as you're going through it. It saves you calculator work during the process. You only have to do the divide by 4 at the end. I still haven't really shown you what the 1 and the 4 are on the top and bottom. So when I said sum is add up, what we're going to do is we're going to plug in values for I from 1 to 4. So 1, 2, 3, and 4. The number on the bottom tells you the start number. The number on the top tells you the finish number. That's what those numbers are for. So what this means is we want, there's going to be a 1/4. I don't want to forget about the 1/4. Then we have, let me put a big old parentheses here, a big old bracket. We're going to do 3 times, we're going to place I with 1 minus 7.5 squared. And we're adding. So we're going to add, the next one is 3, and that next I is 2, so we'll replace I with 2 minus 7.5 squared. And the next I is 3, so we'll replace the I, and it becomes a little bit of a pattern here. You see that everything looks the same other than just one value. And I should have a bracket there. Damn it, I didn't give myself a lot of room. I fucking didn't know how far I was going to take. That's like what's going on. I think it's easier to just make a little list. I hope you guys think so too. One, two, three, 4. I'm going to do 3i minus 7.5 in the first column. In the next column, I'm going to square that value. So I have 3 times 1 is 3 minus 7.5. This is negative 4.5 if we follow order of operations. If I do 3 times 2, I get 6. 6 minus 7.5 is negative 1.5. If I plug in 3, I have 3 times 3 is 9. 9 minus 7.5 is positive 1.5. If I plug in 4, 3 times 4 is 12. If I subtract 7.5, I get 4.5. Don't assume this little like negative and positive values like being the same on top and bottom is going to show up every time. This just happens to be the way it was constructed. The problem was constructed. It can be any value. So don't just assume that they're going to be the same. When I square them though, it doesn't matter if I put in negative 4.5 or positive 4.5. When I square it, which I have an x squared button here, it's 20.25. That's the first value and the last value. So if you've already squared a number, don't square it again when you're doing the list. I don't know if the homework has you doing one of these like, I know the homework has you doing one like this for the support course. I don't know if they do in the main stats part. If I do 1.5 squared, I get 2.25. So what I really have at this point is I have 1/4 times 20.25 plus 2.25 plus 2.25 plus 20.25. I've just done all the like complicated shit in there. Now I just need to add this stuff up. I need to add it up and divide by 4. Or multiply by 1/4, but I think in the calculator it's easier to divide by 4. If we add those up, we get 45. And if I divide 45 by 4, I get 11.25. So that's my value up here, 11.25. That's what that summation thing means. You guys ready for some more? I see Pin's still going. What am I asking? Why am I asking? You bored, Madison? Maddie? That's too bad. Would you like me to make it harder?
No.
But then you wouldn't be bored. It'd be challenging.
Okay, but
You don't want
the
it.
class doesn't want it to be harder.
Thoughtful. You don't want to get, let's go play it. Is everyone good? I enjoy when students ask for more shit, because then I'll do it and then anyone starts calling, I'm like, hey, one of your students wanted, one of you guys wanted to know. I'm talking about it. All right, so let's go back to that shitty problem, the shitty formula, standard deviation. We have everything we need to know. I'm gonna write it down again here for you. Does anyone in this room have a problem revealing their age? If you don't want to say how old you are, speak now. Or I guess you could lie when I ask you. Let's go with that. We're going to find the standard deviation of our ages. I'll go first. We've done the how old David is, right? We did that on the first day, right?
Yeah.
Okay, so I am 48. Let's start here and go that way. Leave me off, Cody.
19.
Next.
34.
Could have lied if you didn't want to give me the right one. 20.
17.
Oh yeah, I knew, I wasn't sure if it was 16 or 17.
19.
Right. 18.
And
18.
what?
18.
18. Look at you guys. You guys actually fucking showed up. My morning class. These are the ages of the people that showed up. Nobody below the age of 24. So I was talking shit about people your guys' age. I'm yelling at them, I said, shut the fuck up, come to class. But you guys did, you guys are a good representative for your age group, excellent. All right, so one of the first things we need for this formula that shows up every time we do this, because we're gonna do this summation for the X, these are my XIs. I mean, stop there. These are my XIs, so we're gonna plug those in one at a time when we do the summation. We're gonna make it in a table when we do it. Each one, we need X bar, or the average, when we do it. So we need to figure out what X bar is. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 entries. N equals 9, that's the sample size in this room. We're gonna use that for our average because we divide by the total number. But that N is also gonna go good here. So N minus 1 for later on is 8. We're gonna need that too. Let's figure out X bar. It's 48 plus 19 plus 34 plus 20 plus 17 plus 19 plus 20 plus 18 plus 18. Then we're going to divide by 9. Just showing the other class with all the people that are in the 30s make you feel better.
9.
A little bit. You're all these young, like 18, 19, 17, you're like, shit, I feel old. Morning class has people all your age, so you're young, I feel old. And if you feel old, there's always that old buck in the front of the room that's even older. All right, someone do this with me because I'm gonna fuck up this calculator, so just do the adding part first. Let's make sure we get the same value on top because I don't want to add it twice. I got 213. Is that what you got? Okay. So X bar is going to be 213 divided by 9, which is going to be a fucking shitty decimal. God damn it. 23.66666666. I'll do like 23.67. We're going to use that for X bar. That'll be our X bar. When we get to the end, we'll just round it 1 decimal place. So here we'll do 2. Now I'm going to make a table. In my table, I'm going to put my XIs, which is us, our ages. 48, 19, 34, 20, 17, 19, 20, 18, 18. And then I'm going to do, in the next one, I will do XI minus X bar, which is 23.67. And I'm going to work smarter than harder. Once I do the 19, I can fill in the 19 down below. 48 minus 23.67 is 24.33. 19 minus 23.67 is negative 4.67. And that's my 19 down here. 34 minus 23.67 is 10.33. 20 should be negative 3.67. That's one I can do in my head. 17 is, it should be 6.67. Let me check though. And the 18s are both going to be negative 5.67. In the next column, we're going to square that last column. So 24.33 squared is 591.95. 4.67 squared is 21.81. 10.33 squared is 106.71. 3.67 squared. This is 13.47, and I'm doing rounding to 2 decimal places each time. So I'm rounding. $44.49. $32.15. Now, the next thing we have to do is we have to do the summation thing. Summation is next. So I'll just write what that value is in the next column after I've added it up. Someone else add these numbers up with me. I'm getting 878.01. Did you get that too? Okay, good. I'll assume if 2 of us got it, we were right. So now we're at the point where this is what we're looking at. We're looking at S equals the square root of 878.01 divided by the n minus 1 equals 8. So first we'll do the 878 divided 0.01 divided by 8. And this gives me 109.75. I'm seeing 125, but that doesn't really matter here. And now S is going to be the square root of that. And for me, on my calculator, if I've already got an answer in there and I don't want to retype it up, I can hit the square root key and then I can hit answer and it will grab the shit from the screen and put it in there. And I am getting 10.476. Maybe we'll do 2 decimal places, 10.48. I probably should do 1 decimal place. Let's do 10.5. This is in terms we were talking about years old, so the standard deviation here is in years. I don't know about you, but that sucked butt. So, how is there a quicker way to do it? I'll show you after everyone's done writing stuff down, getting caught up. I don't want to, yank the shit too early. Everyone ready? I am gonna go over to the computer. And in StatCrunch, I'm gonna type those numbers in for our ages. We had 48, we had 19, we had 34, we had 20, 17, 19, 20, 18, 18. All right, so I've got our ages in variable 14. So to do this in StatCrunch, you're gonna go, and it shows it in, well, it's in the videos as well, you see it in there. But if you go stats, summary stats, columns. You pick the column where your data is. My column is variable 14. We wanted standard deviation. I'm gonna do mean also. Make sure our mean was right earlier. I assume it is. There is an unadjusted standard deviation down here. I'll show you what that is in a little second. But the one we want is this one. I click compute and we got 23.6667. That was our mean. We got that. And we got the 10.476. And then after that, the numbers are different because we rounded. So rounding to 1 decimal place, 10.5. This was way faster. That was just 9 of us. There's a lot of operations to fuck up on. Even if there's only 5 entries, 4 entries, you are doing a lot of operations there, and all you gotta do is push a wrong button in a calculator once, and you get the wrong answer. So you're better off like putting stuff into a program that does it for you. I would double check your data when you do it. If you're doing homework, you should be able to just do the open in StatCrunch and it'll copy it all for you. And then you don't have to worry about even typing anything wrong. All it is you just need to remember stats, summary stats, columns, telling it where your data is and what you're looking for. In this chapter, in chapter 3, you're also going to be looking at, you'll look at min, Q1, median, Q3, and max. And maybe I won't do it for us because it's a small group. Maybe I'll do the age of the actual, like the stuff that was looking at. When you're going through chapter 3, this is called the 5-number summary. It's near the end of the videos. Min and max are exactly what you know them as, the lowest age and the highest age. The min, and what in terms of what these are, min is 0% of the population or your sample is younger than that. Q1 or quarter 1 is 18. It means 25% of the people are 18 or younger. Median is the halfway mark, which is 50%. 50% of the people in this group were 21 or under. Q3 is like 3/4, 75%. 75% of the people are below 32. And then max is 100%. 100% of the people were 79 years or younger. That's what those mean when you get to those in the video. You'll see them again in the video. But that's how you do standard deviation by the computer. Not too bad, right? Much quicker. Now, you may be wondering, well, what the hell is standard deviation? What is that deviation of our age being 10.5 mean? So I want you guys to find the mean, 2 different data sets. This will be a quick exercise for you. 10, 30, 50, 70, and 90. 48, 49, 50, 51, 52. Write it out, do it on your calculator, figure out the mean for each group. Give you another minute, we'll be done. Here's a fun story, all these Greek letters. When I went to grad school at Santa Cruz, my math teacher was from England. My advisor was from England, and another one of my teachers was French. And she didn't make fun of us, but he made fun of us all the time. In math, we use X, Y, and Z a lot. We're the only fucking country that calls it Z. Every other country in the world calls the character Z, Z. The reason why we call it Z is the alphabet song. The American that came up with the alphabet song, you know, Q, R, S, T, U, V, W, X, Y, and Z. Z rhymes with V. It sounds better than Z, so he changed it. So he made fun of us all the time. Stupid Americans, you don't even know what your letters, how to say your letters. Well, what he didn't know is one of the students in my year was Greek, and she was from Greece. She knew a lot of Greek letters. She knew how to speak the Greek language. So, and the reason helpful I'm telling you this is we will see this letter later on. This is alpha in the Greek letter. This is spelled that. If you're older than 30, you probably have seen that, well, maybe not. I'm like almost 50, and I don't know that I was alive past 10. There used to be a VCR back when there were VCRs. Fucking you guys don't even know what VCR is, most of you. Before the VCR, the VHS was beta. So he would pronounce it beta. And she said, you stupid English person, it's beta. It's really pronounced bet. And so we made fun of him, and then when I really thought about it, it totally makes sense. We call our language the alphabet. Alpha, bet. Alpha, beta. That's where alphabet came from. It's the first two letters of Greek, the Greek language. That's why we call it the letters of the alphabet. It's not alphabet. So that's the way I remember it every time I do it. But it was fun because he wasn't being mean. He was just being a jackass. I'd be a jackass once in a while. I'm not trying to be mean. I'm just trying to have fun with you guys. All right, so I'm assuming you guys all got the mean on these was 50. I hope you got 50. So, but we can see that they're drastically different data sets. So the mean doesn't give us the whole picture. It gives us what the average is, but the standard deviation, let's take a look at what the standard deviation does. I have these two sets of numbers already in here from when I did this morning, of course. And let's do our summary stats on those two columns and find our standard deviation. That's column 15 and 16, so I'll select those and I'll say I want standard deviation. And data set 1, I'm going to write down real quick. It says it's 31.6 for S. Data set 2, it says 1.6 equals S. So I pulled that rather than doing that table thing again. I only want to do that table once for each class because doing that, it takes a while. It's tedious, right? This gives us more information. What standard deviation is showing us is information frequently abbreviated, unfortunately, std.dev, is how spread out the data is. around the mean value. So high numbers mean high spread. Higher spread. Now, when you're watching the videos, we'll talk about like actual problems where like looking at like when do we want like a high standard deviation, when do you want a low standard deviation? One example I could give you would be like playing the lottery for high standard deviation. Your average winnings tend to be kind of low or negative. Your average winnings tend to be negative, but you only got to hit that fucking mega jackpot once, right? Whereas if it was a low, the standard deviation on winnings is really high. It's really fucking high. The standard deviations of something like where it's really small means you'll win some, but you like if it was related to gambling, you'll win some, but you won't win a lot at any given point. So if you really want to have a lot of money, you got to do doing it a long time and get really lucky. And that shit doesn't happen. The longer you're gambling, you're gonna lose. In fact, in chapter 5, when you're going through that, we look at some stuff in casinos, how roulette and stuff like that works, how the house always wins. We got one more set of topics to do for today. Then we'll stop for today, give you guys a little time off early, start knocking out some of this homework. Is there any questions so far on this? Are we having fun yet? Maddie, did you at least like the alpha beta story?
Yeah.
Okay, so there's at least some value in entertainment there. I'm not just boring you all the time. The math may be boring, but Mr. Jones isn't. Mr. Jones is fascinating. If you didn't read the whole, how many of you read my whole introduction? How many of you just fucking did the introduction and said, oh, there's the assignment, and scrolled down and did it? Only, I bet most of you fucking didn't read it. It's a shame. One of the things I tell in there is the time me and my wife visited the Four Corners, which is a location in the United States where Nevada, Colorado, Arizona, and New Mexico meet. All states, they all meet in like a perfect corner. There's Four Corners. It's on one of the Indian reservations. I don't know if it's Navajo or something like that. It's on Indian land. But they have a little plaque there. And it's probably not in the right spot. There's a little plaque there. And when you visit there, you can stand on the spot and be like, I'm in 4 states at once. Well, and you take picture, you can give someone your camera and take a picture of you doing it. Well, I was in line and I had to fart. Me and my wife were there and my mom, or was it my mother-in-law? One of them was there. We don't take them. And I had to fart. And I'm like, I don't care about doing it around other people. Didn't give a shit. Like it's a natural thing. Especially outdoors. You're not gonna get any of that. So I waited till I was standing on the Four Corners. And my wife was taking the picture. And she knows enough that she could tell my facial expression when I'm doing it. Like, I guess my face goes like lax or like no expression for a little bit. And I saw her like she lowered it, squinted at me, did it again, and took the picture, and then she asked me afterwards, did you do it? I said, hell yeah, I did. I farted in 4 states at once. Fuck you all. It was great. It's a great story. Most of you didn't even read it. All right. There's another fascinating story you can tell your parents, your boyfriend or girlfriend. All right, other stuff we're gonna be doing in this section is algebra stuff. So let's talk about algebraic expressions. This is your math that has letters in it. These letters are called variables. That's what they're called. And we call them variables because they vary in value. They don't have to be one specific amount. So examples of this is like 3x plus 5. We could have a decimal in there, 0.23y minus 0.423. My variables are my letters. The numbers that come in front of them these are multiplied by the letters. These are called coefficients. The word comes up a couple times in this semester. A lot in chapter 4. It's a long word for I guess it's a long word, but it's shorter than saying the number multiplying by the variable. We have a couple rules that we can use in this. There's the distributive property. And it sounds like the word distribute. And this is like the whole how the Oprah Winfrey show used to be a long time ago. And you get a prize, and you get a prize, and everyone gets a prize. She distributes prizes to all the people in her audience every once in a while. In terms of math, it's taking a number that is multiplied by a parenthesis. And what we do is we distribute it. We're going to take the 2 and multiply it by the x. And then we take the 2 and we multiply it by the 3. And we don't leave it like that. We will do the 2 times 3 is 6. And rather than showing the dot between the 2 and the x, we don't put the dot. If there's a number in front of a variable, it's implied to be multiplication. Why? Well, if we did order of operations, we would add the x and the 3 together, right? But if we don't know what x is, how the fuck are we going to add 3 to it? Like if I don't know how old you are, I don't know how old you're going to be in 3 years. That kind of idea. But just to show you that it kind of works, this isn't like a proof or kind of anything like that. But if you looked at like 3 times 1 plus 4, and we distributed here, and we had 3 times 1 plus 3 times 4. On the left side, we could do our order of operations, and 1 plus 4 is 5. And we have 3 times 5. And 3 times 5 equals 15. And when we do it over here, after we've distributed, 3 times 1 is 3, 3 times 4 is 12, and we add them together and equals 15. If you have an actual value in there instead of the x, you won't distribute, you just do the order of operations, it's quicker. It saves you some time. But we don't often have it. We will do more stuff with that tomorrow. We're going to do a lot more stuff with all this tomorrow. One more page of notes. We're getting out of here like maybe 20 minutes early, maybe 25. Unless you all want to stay the extra 25. Maddie, do you want to see more math? Okay, so if you're bored with the math, and but you're going to be using statistics in your whatever career you're in, you may not even know it. A lot of jobs use statistics that you don't know. you can do statistics at a calculus level. In fact, the better way of doing statistics is at a calculus level. This is just like introduction to stats. But the good shit requires hard math. So you could do stats where it's not boring. That was a fun class. Okay, I'm gonna eat up a couple more minutes of your time. I took stats here, and when I had to do it, we didn't get no fucking computer to do it. I had to do all that table shit. That's what I had to do. It sucked. There were very few problems on any test because it took forever to do a goddamn problem. It's really hard to get the problem 100% right because you could just screw up basic multiplication. But when I transferred to UC Merced, when I transferred, I had done like this internship in North Carolina. And I didn't get to register until I got back, which was like July. Everybody else had registered in fucking May or April. And so there wasn't a lot of classes for me to pick. So I took the stats again. I basically took stats again there because it was at a higher level. It had some calculus in it. And I'm sitting in there and it's like a large lecture room. Oh, this wasn't the stats class. This is the chemistry class. Either way, but we're just going to switch to chemistry here. It was a chemistry class. I'd done chemistry here as well. And the guy's going through the grade, how the grades are determined. He said 90% to 100% is an A. 75% to 90% is a B. Now, normally it's 80% to 90%, but his was 75% to 90%. A C normally is 70 to 80. A C in his class was 55% to 75%. You could get a 55% in class and still pass the class, which is barely better than doing half. Like 50% is getting half your problems right. Someone immediately raised their hand and asked, will you be grading on a curve? And I couldn't help it. I fucking laughed out loud. At the universities, some of the classes there, like the general ed, it's in a fucking auditorium. There's like 300 people in there. My laughter, I'm like in the front row, off to the side, and I just burst out laughing. He's like, now be nice, it's a legitimate question. He's like, no, I will not be grading on a curve. The curve is kind of put into the grading thing. And I'm like, if you don't feel confident you can get a 55% in a fucking general ed course, maybe you shouldn't be going to college. Or whatever it is you do in your free time, you should be studying instead. Maybe you just don't study a lot. How wrong I ended up being when like at least half that class failed the fucking class. The tests were multiple choice. It gave you answers and you got to pick one. Yet over half the class still failed. Now, in their defense, he was a dick with multiple choice questions. He took like the 3 most common ways that you would make a mistake, and he calculated what the answer would be if you made that mistake, and put that answer as one of the answers. So you could do it one of the 3 most common mistake ways, see your answer on the test, and go, fuck yeah, I got it. Right? Usually when you see your answer on the test, you're like, I confirm I did it right. No, not in his class. It meant nothing. When you got the answer that's on the exam, it meant nothing. The only like reliable answer was when you didn't match any of them, and then you knew you did something wrong and you go back and fix it. But you walked out of that test usually like, I don't know how I did. Not after the first one. Everyone was confident with the first one. And then like most people failed it. All right. That was a nice little delay there. One more little thing is the commutative property. Oh, there's 2 things. Commutative property and evaluating expression. So the commutative property, that should be 2 M's here. It kind of looks like the word commute. And like if you commute to work or commute to school, it's like how you move around to get to work or get to school. So commuting in mathematics, the commutative property is when the numbers move. Examples of this are like A plus B equals B plus A. I could switch the order of addition. 1 plus 4 equals 4 plus 1. There's also the multiplication version. I can multiply two numbers together, and it doesn't matter which order they show up as. A times B equals B times A. 2 times 3 is the same thing as 3 times 2. They'll have like stuff in there, like showing which one of these shows the distributive property. You'll use it, but not very often in here. Like very rarely are we really doing a lot of distributing in the actual stats course. The commutative property, I can't think of a goddamn time I've ever used it in mathematics when doing something on like paper. When I use the commutative property, it's when I'm doing like math in my head. So I'm going to show you and like explain how I would do it. Let's say I had the numbers 7 plus 5 plus 3 plus 10. Now, when we do adding left to right, 7 plus 5, let's try pop the pause and think about it as 12. 12 plus 3 is 15. 15 plus 10 is 10 or 25. Depending on some of these numbers, like when I add 9 to something or when I add 8 or 7, it slows me down. I really have to stop and think about what the answer is. When I do math, though, I look for values that add to 10. I know 7 and 3 add to 10. So I could change the 5 and the 3 and put them in a different order. And then I'm doing these. I do 10 here, and then I add another 10 here, and I get 20. And then I finally add the 5 and get 25. That's the way I do math in my head. I'm always looking for multiples of 10 because it lets me keep a running total in my head. Multiples of 10 are easy to remember. It's easier to remember 60 than 63. I don't know where you're really going to use it in this class. It might show up. If it does and I see it, I'll go, hey, look, it's there. But I can't, it's not popping in my head anywhere. The other thing we have in this section, we're going to be doing more with it tomorrow, is evaluating an algebraic expression. And we kind of did stuff like it already. This is kind of like what we did with the summation, with the I in the summation. So we had 3I minus 7.5. And then we said, what is this value if I equals 1? Evaluate means plug the value in, replacing the variable. I recommend when you plug it in, you use parentheses. Earlier I did 3.1 minus 7.5. I shouldn't have. I really should have showed the parentheses. And the reason why is sometimes, like if you're doing with a pen or pencil and not a fucking thick tip pen, that period, that dot doesn't show up very big. And if you, like a car horn goes off or the dog barks, or you look away and you look back and you don't have the dot and your 1 is like closer to the 3, you might see 31 rather than 3 times 1. So like putting the parentheses in helps. We saw then we do the order of operations. Then do order of operations. Then we hit our PEMDAS. So 3 minus 7.5, negative 4.5. That's what evaluating an algebraic expression means. Plugging in a value for the variable and seeing what the total will be. Any questions? If you're done writing stuff down, you can get the fuck out if you want, or you can stick around for another 20 minutes. You can tell me how your day's going. Or you can ask questions. I'm here till well, I'm going to be here all day. Any questions, Guadalupe?
Yes, I have a question. So on Canvas on the calendar, it shows an assignment, the 160 hours in a week too, but there's nothing under it. So I was just making sure if it is an actual assignment or not.
I don't know why that's showing up. Someone emailed me about this yesterday too. I need to go through and get rid of it. If you see something that says 168 hours in a week assignment, there's no assignment. That's for like like a semester that's 16 weeks when you actually have time to do like a little calendar assignment. That's when I do it there. It's really like to help students like plan your week 1 week and then try to stick to like your study plan and then see how it works. Well, like trying to do that right now, you really don't want to do that. So there's nothing on that one. Anything else? All right, see you later.